Welcome back. Let's talk about relational database. Now, you might be familiar with some databases from the information technology world. There's Microsoft Access on the personal computer platform. There's Oracle. Oracle's more of a high-powered industrial database with a very profitable marketing and licensing strategy. And then there's something called MySQL, which is part of the LAMP stack. So you've got Linux, Apache, MySQL, and PHP. So this is a little bit more of an open source kind of a thing. And then there's Mathy RDB, which is what we're going to do. This is us. This is this class. So the reason I'm pointing out the differences between these two is these guys here are more of information technology world, industrial, real world databases, which are really important. And if somewhere along your educational career, hopefully you'll take a class in one of these, but if it's not required, then I highly recommend that you take a class, just like a whole semester in one of these guys. They're all kind of the same in the theory part of it, because this stuff is super important. I've written a lot of code for money, and while I don't consider myself a database expert, almost all of the code that I've written had to access a database in some way just to store the data. Because data is, rarely stored in, well, sometimes it's stored in individual files, text files and things. But if you have a whole lot of data, and that data is related to any kind of, production environment, then you need need to access the data store and that is in a relational database. Anyway, so that's really important, and you need to learn that. And some of you may have some background in that, but what we're doing is a little bit different. Okay, so some of the things we're doing actually might make you cringe a little bit if you have some knowledge in this stuff, because in the industrial database stuff, there's these data normalization rules, for example, and all of that is to ensure the data integrity. So we're going to kind of skip some of that stuff, and that might bother you if you have some experience with databases, especially if you're a database administrator and you deal with that stuff all the time. Okay, so that's pretty much what I'm saying in this first paragraph of the notes here. All right, so we've got these tables. Databases consist of tables, and the columns in those tables are known as fields, and the fields correspond to a set name. The rows are known as records, and the records are basically n tuples. So the table itself is a relation, because the table itself is a subset of the Cartesian product of all the sets. So here's an example. Well, actually, before we get there, there's this term relation in a relational database. Now, there's two separate meanings of the term relation, but those meanings are not completely separate. It's a little bit confusing. In fact, let's look at a table here, and then hopefully I'll remember to go back to that. So here's a table called customers. So it has rows, or also called records, and then it has fields, also called columns. So the field names are name, city, and type. And those field names correspond to sets. So there's a name set. So these are the original three sets. We have name, which has Bob, Sam, Sue, and Tim, and city, Folsom, Rockland, Placerville, Auburn, and then all these blood types. So you can form a Cartesian product on these three sets: name cross city cross type, and it would have a whole bunch of elements. The name cross city cross type Cartesian product of these three sets. How many elements would it have? Or in other words, what's the cardinality of name cross city cross type? Well, it's the cardinality of name times the cardinality of city times the cardinality of type. So 4 times what? 1, 2, 3, 4, 5, 6, 7, 8. 4 times 4 times 8 is a whole bunch. So name cross city cross type is a big set. But we can form a subset of that called customers by pulling out just these rows, which correspond to actual people, presumably. And this is for a blood bank, I guess, because it's talking about blood type. Anyway, so this is a table, also called a relation, and it has fields, also called columns, which correspond to the original sets, and then it has records, which are the elements of the relation, or each record is a tuple. And each record, is a tuple drawn from the original Cartesian product. Okay, so that's what we mean. That's what we mean by a relation. That's one use of the term relation, is this right here. So there's another use of the term relation, which is separate but not exactly separate. So look, we got a table here, and you could have another table. So each table is a relation, right? Each table has fields and columns. It's so this is a relation, and this is a relation. But there's another use of the term relation, and that is, in a relational database, there's associations between records, and there's associations of various types. Could be one-to-one, could be one to many, could be many to many. And if you're a database administrator or you've taken a SQL class, then you've dealt with this. So this right here is called a relation as well. Okay, so it's two separate uses of the word relation. One use of the word relation basically just refers to a table. And then another use of the word relation refers to this association between tables. Now, to make this a little bit more confusing or a little more complicated, is that these are not exactly different. That is, there's a reason why this is like that. Okay, so I'm just going to leave it there. That you can think of these as separate uses of the same word. That is, the word relation meaning two different things, but it's a little bit more complicated than that. All right, so just kind of file that away in your brain there. All right. Okay, there's this other idea, if you're a database administrator, you may be familiar with, and that's the idea of a key. Now, we're not going to really mess with a key, but it is an important concept, so I'll go ahead and talk about it a little bit here. But look at this guy right here. There's two Tims, right? But they live in different cities, so presumably these are different Tims. So the field name is not enough to identify this Tim. If you just say Tim, hey, I talked to Tim the other day, it's ambiguous. You have to specify the city that Tim's from, because it's two different Tims. So that's the idea of a key. The idea of a key is a combination of fields that's enough to uniquely identify somebody. So in this particular data set, city and person would be enough, to identify Tim from Rockland as separate from Tim from Folsom. But you could have another Tim move to Rockland, and then it would get ambiguous again. So you usually have it takes several data types, like name, city, and shoe size, or name, city, and blood type. But you might be able to see the problem with that is that if you just build a key by using multiple field names, conceivably it's possible for somebody that's a doppelganger, somebody that's identical to somebody else in a lot of different ways, to be confused with another person. So the best thing to do is have a customer ID field, which is just a number that's unique. Okay, then you're guaranteed that the data is unique. So we're not going to do that, and which is one of the things that if you're a database administrator may bother you, because it's a really good idea to have an ID field in every single table to guarantee that you have unique data. So I have some experience from industry, and if people don't trust your data, then it's useless. So I've experienced that. So you really need to maintain the integrity of the data, otherwise people will just run away from your database and not want to use it. So anyway, that's the mathy kind of thing. We're going to do some things that, you know, in the real world you wouldn't want to do. Like we're going to not have keys, even though you should always have keys. All right. So we got these relations, which are just tables, and we're going to have some fun by doing some operations on the relations. So we're going to take, well, some of the operations will be performed on one table. So they're unary operations because the operand is just one table. So we call that a unary operator. And then we're going to have relations that are binary relations. That is, the operands are two tables. So we call that a binary operation. So these are the three operations. Once again, if you have experience with a industrial real-world database, these operations are kind of like some operations in SQL, Structured Query Language, but they're kind of different. I'm just going to point that out, and if you have some SQL training, then you'll understand what I'm talking about. And that's all I'm going to say. So a select operation a select operation extracts rows from a relation. It just pulls out particular rows or particular tuples. And a project operation extracts fields from a relation. And it also eliminates duplicates, which is kind of like a group by in SQL, by the way. And then there's a join. So a join is a binary operation. It takes two relations or two tables and constructs a third table according to a condition between the shared attributes, which is a little bit like a relation, the condition between two tables. It's a little bit, but not exactly. All right, so the best way to understand these is just look at some examples. Okay, so let's do that. We need kind of a lot of real estate to make this happen. So from our textbook that we've been using, we have these four tables: employee, department, buyer, and supplier. So each one of these tables is a relation. That is, each one is a subset of some Cartesian product. So here we have ID, name, and manager are the original. We have a set called ID, and then we have a set called name, and we have a set called manager. We form the Cartesian product of those three sets, and then we extract some rows from that Cartesian product, and that's our relation. So we've got 1, 2, 3, 4, 5, 6, 7 tuples in this relation. And likewise, so here's department is another table. It has department field and manager field, and department shows up here again, and part number shows up here, and amount and name and part number over here. So these four tables, they share particular fields. Like this guy has a name field, and this guy has a name field. So we could link those on the name field later. This guy's got a manager field, and this guy's got a manager field, so we could link those guys. And let's see, this guy's got part number, and that's got part number. We could link those. All right, so let's just do these three operations by example. All right, so select extracts tuples, rows from relation. Well, before we do that, just to point out that this is a relation, and to tie this back to the math that we've been looking at, this is what it looks like in set theory notation. This is what department looks like, right? Department is a set of ordered pairs in this case, because there's only two fields in this guy, so the elements are ordered pairs or tuples with TWO for tuples, right? Okay, 23 Jones, 04U, 96 Zamora, 66 Washington. So this is just to relate what we've been doing already with set theory back to this table representation. All right. Now let's do a select, a project, and a join. So I'm going to move this over here. It takes a lot of space to do this stuff here. So here's a select. Let's see if I can point at the right stuff. So we're dealing with the supplier table. Temp1 equals supplier, department equals 23. So we're generating a new relation called temp1 by doing a select operation on the suppliers table where the department field equals 23. So basically we're selecting the rows out of supplier that have 23 in department. Right? Selects rows, and it does that by looking for a value in a particular field. So you just kind of scan down this guy. How would you do that if you were writing a program, right? I'm going to talk about that in a minute. But what would you do? You'd scan down this row looking for 23 in department. And when you find it, you'd scan across, copying all the data into the new table. So you'd copy 23, 2A, and 14. Then you'd scan down until you get to this other 23, and you'd copy 23, 777, and 70, and 39, right? That's what you do. So this is a select operation. It just selects rows. Okay, moving right along. Here's a project operation that now I don't want to use the word select, but it chooses columns. It chooses particular columns. It's hard to not use the word select because I don't want to confuse it with the select operation, but it's choosing particular columns. So we're operating on the department table, and we're choosing the manager column. So all the data in the manager column just gets copied down. Jones, Zamora, Washington. So you could generate tables with more than one field selected. Then it would be like, say, manager, comma, department. And that would, of course, in this particular case, would just make a duplicate of the entire table. But how would you write this in code? What you would do is you'd start here, and then you'd run across the field names looking for the fields that were selected. So you'd run across here, you'd say, well, manager was selected, so then you'd copy Jones down. Then you'd go down to the next row, and the same thing. You would skip department, because department is not selected, and you'd get to manager, and you'd copy you down. So you'd be running down this way in a loop, down the rows, and then for every iteration of this loop here, you'd be running across the top, checking for a particular field name, manager in this case. All right, that's a project operation. All right, then the harder one, moving right along now, is a join operation. So a join operation combines two tables and generates a third table. So it's a binary operation. It's operating on the temp1 table that we've already created right here, and the buyers table. So it's operating on this table, these two tables, the temp table and the buyers table. And it's looking on part number. It's looking for a match on part number. And what it does is when the part number matches, like 2A is going to match, it's going to combine all of these fields into one row. So look, this one has 1, 2, 3 fields, and this one has 2 fields. One field is shared, so you're going to have 4 fields. Basically, you're going to have all the rows in this table, plus the additional rows from the join table. In other words, it'll do department, part number, and amount. Department, part number, and amount, and then it'll throw in the name field from this guy. So let's be a program and do that. How's this going to operate? You're gonna iterate down this row. Let's use this one as the first table because it is the first operation in here, temp1. So we'll iterate down this row, and then we'll iterate down this row. So what are we going to do? We're going to start here, and we're going to look at part number and see if it matches, and it does match. So then what do? We start copying. So we copy United Supplies and 2A into here. Then we go over here and do the 23 and the amount. We'll skip part number because we already got it. It's the shared field. We don't want to copy that twice. Okay, so we'll do that. Then this guy will increment and check on part number. No match, right? Because 2A does not match this guy. So for this first row, you're going to scan all these rows and look for 2A's. You'll find a 2A here, and we did that, and then you'll find a 2A here. And so for this these two rows here, you're going to copy 23, 2A, and 14 again. 23, 2A, and 14, and then you're going to copy JCN Electronics. And you'll keep scanning for more 2As, you don't find it. That was the inner loop. It's actually a couple more than just 2 loops. This is the second loop. You have the outer loop here, and then we'll call this the second loop. But there's a couple of loops going like this too. We'll look at that in a minute. But anyway, so we start here. To summarize, we start here, we get all the 2As, then this loop over here increments, and we start again, right? And we look for 772s, and we find one here, and we copy all the data in this row and all the data in this row, and we get this row down here. Okay, then we scan down here, we find another 72, we copy all the data in this row into here, and all the data in this row into here, and we end up with this row. That's it, that's a join. All right, let's look at a couple more examples. You need paper, you need space for this here. Yeah, so I know for some of you, I know it's kind of small on your screen, but you know, you could use your TV if you have a big TV. You could watch me on the big TV. Anyway, find the names of all employees who are managed by Jones. So this is just this is a select and then a project. So to write these, in your homework, you're going to be asked to generate these. What do? It says names, employees, manager, Jones. You kind of look for that information somewhere, and you're going to find it. You're going to find it. Some of it here, where you have name and manager. So this is the employees' names and then their manager, and that contains all the information we want, but we're asked to find just the names. So first we'll find particular rows, the rows that have Jones as the manager, right? We'll find these 3 rows, this one, and this one, because they have Jones as the manager, and then we'll pull out the names, just Kaminsky and Schmidt and Manicotti. So the first operation is a select, where we're just scanning the manager field for Jones, and if we find it, we copy this whole row here. So we copy this whole row, then we copy this whole row, then we copy this whole row, and we got that stuff. Then all we got to do is pull out these names right here, and we use a project for that, right? So we generate temp1, which is this guy, by doing a select on the employee table. Then we generate temp2, which is this guy expressed in set notation instead of a table, but it's still a table. We generate this guy by doing a project operation on temp1. Okay, that's another example. We got more, we got lots. Here's another one. And this one we'll look at in extreme codiness in a little bit. So find the part numbers and total amounts of all parts for the parts bought by United Supplies. So there's going to be these 3 operations, it turns out. How do we know? Let's kind of walk through this a little bit. So we got part numbers. Where does that show up? It shows up here in buyer. It also shows up here. And the total parts, that shows up here in supplier, the total parts. And then the buyer shows up here in this thing. So we know we got to do a join between these somewhere along the line, right? Because the data United Supplies is in this guy, and parts and their amounts is in this guy. And they share the part field, so that's what we'll join on later. Okay, so we could simplify it by just pulling out United Supply out of the buyer. So this guy, this table here pretty much represents the parts that United Supplies supplies. So what do? You do a select operation. So you're gonna run through, you're gonna iterate through these rows here, and when you see United Supplies, you're gonna copy that whole row over. So you copy this whole row over to this table and this one, and then you copy this one, and then you copy this one. So you got all the rows on there. Then we need to do a join to pick up the part numbers, right? Because these parts 2A, there's 14 of those guys, 11 99C, there's 296 of those guys. We're trying to count the part numbers, right? So 33522B2, there's 220 of those guys, and then this 772, there's 39 of those guys. So we got to join on the part number, right? So we're joining on this temp1 part number with supplier part number. We're joining the temp1 table, this table, with the supplier table, this table over here. We're joining on part number. Well, we're joining on part number in these two tables here. So what do? You if this is the input, or this is the first table, then you would iterate through these guys looking for matches in these guys. So you'd start here, and you'd scan down this guy this way looking for 2A, and you find one here. Then you copy all of that information into the resulting table. So you're going to copy United Supplies and 2A, United Supplies, and where's 2A? I think I'm doing this backwards. Yeah, it looks like the results here, it looks like this supplier table was the first table. Yeah, that's the way the data is coming out. Okay, so we're scanning down this way first, looking for a match on 335B2. Okay, so we start here. We start here where my pen is wiggling, pencil is wiggling. We find a match here. So we copy 04, this thing, and this thing. We copy those down here. Then we tack on United Supplies onto the end of that. Then the outer table iterates down. Now we're looking for 2A. We find it here. Generate this row. No more 2A's. So the outer loop iterates. Now we're looking for 8C200. We don't find it. Reset the inner loop, increment the outer loop. We're looking for 42C. We scan, don't find it. Look for 900, scan, don't find it. Look for 20A8, don't find it. Look for 1199C, find it. So we copy 96, 1199C, and 296, and then tack on United Supplies from this table. That was for 1199C. And then no more 1199Cs, so the outer loop increments here, and we're looking for 772. We scan down here in the next inner loop, and we find it, so we copy 23772 and 39 down to this guy, and then we tack on United Supplies from this guy. So that's basically it. Then all we need to do is extract the part numbers. The query is asking find the part numbers and total amounts of parts, so we need to extract these two fields because that's what they're asking for. So that's just a project operation. That's a project operation which extracts columns. So to generate that, you would scan across this way, and if part number is selected, you'd copy across those two guys. Well, part number is selected, so you'd copy it. Then amount is selected, so you'd copy it. And then you'd continue, and then you'd increment on the outer loop, and then you'd scan again. All right, so let's look at some code. I have one more example here. I'm going to leave this to you because I'm not sure. Watching me point and click is always the best thing. Point and talk. So this is an extra one for you. But let's look at what this looks like in code, because I'm going to ask you to implement this. And very shortly, like about 10 minutes, I'm going to ask you to implement this thing. So here's example 4 that we just walked through. And here's, actually we don't need example 4 right now. We can just look at these operations. So let's do that. So let's look at each one of these operations from a coder's point of view. And here I've given you the pseudocode for implementing these guys with these iterators as labeled. So what do we got? For select, remember select selects rows and copies the entire row over to a new table. So we've got two iterators here. We've got I1 and I2. Those are doing the rows. I1's doing the row in the input table, and I2 is doing the rows in the output table. So we have to have two different ones because they're not going to have the same rows. But then we've got this J iterator, which is the same jitterator, jitterator, this J iterator. We've got the same iterator here that's just walking across because both of these tables have the same columns. Okay, so what's going to happen? The outer loop is I1, and I've got these two fields up in, or two variables up in here. I've got the column that you're looking for a match on, which is column 1, and then the value that we're looking for a match, or the value to match, is 42. There's other data in here. I just left it blank so it's not so messy. But yeah, there'd be data in there. So the outer loop is I1, and you're going to start at I1, and then you'll look for a match on column 1. So I indicated that by if match because I want you to write that expression. But if these two elements are a match, then the J iterator goes all the way across, both of them at the same time because it's the same iterator, and you just got to do a copy. So walk J across and copy every one of these elements across. str copy is a good command. str copy. There's other ways to copy strings. These are just strings in here. All right. Then so you're going to copy that, and then J will increment right here. So that says J++. So the hardest part of this, in terms of just debugging, is putting these resetters, resetting the iterators, and when to increment the iterators. That's why I've given you this pseudocode. Okay, so I'm trying to show with indentation where the iterators get reset and stuff, because that'll burn up a couple hours of your life just debugging that. All right, so yeah, so you find a match on 42. If it matches, you run across J and copy all the columns over. Then I2 increments. So you're looking at this row. I2 is incrementing on the there's another. So this is a little bit weird right here, but look where I'm incrementing I2, but there's no while loop matching that. It's because when J is done incrementing, you've completed the I2 row, so you can just increment I2 there. It's only going to go, I2 is only going to go once through this thing. It's not really a nested loop, or that's not really a complete nested loop. Really, I mean, what happens is I1 iterates down, and for everywhere there's a match on 42, I2 will just increment basically. So it's a little bit weird what's going on right here. It's not quite a fully formed loop. Okay, I want you to kind of think about that, and that's why I've given you this pseudocode, which is correct. All right, the pseudocode is correct. I've been using this for years, but there's a little bit of some weird stuff going on in here. There's more than one way to write this, but this way will work here. So anyway, after you found a match and copied all the columns over and then incremented the I2 counter down where it's ready to copy the next row, then the outer loop increments, goes down here, and don't forget to reset J back to the beginning here. Then you check for a match on here. There's no match, so you increment I1. And then you look for a match and you find it. So then J scans all the way across, copying all the data to this guy. And then you increment I2 ready to point to the next row should you get a match. which you don't, so it's done. So that's select, all right? So turn the homework, I'd like you to turn this into, you know, executable code and actually get these guys to work. Okay, let's look at project. Project, there he is. Mask off all this other noise. What do we got? We got a couple of iterators. We've got I and the same I. What does project do? Project extracts particular columns, which I've marked here. So you need to pass in the columns that you're selecting somehow. And what I did is I passed in an array into this function. Okay, so this little array is just marked with the columns that you want to extract. In this case, I want column 0 and column 1. So the resulting table will have column 0 and column 1 because these two boxes are checked. So they're all going to have the same rows. For project, that's why I have the same I right here. Just one row iterator. But they're going to have different J's because not all the columns in the first table come over. So you have two different J iterators. So what do? You scan I, that's your outer loop. You scan down here, and for each row, you scan across J1, and if that column's selected, you copy it, and then increment J2. Right? You check if do you want 0? Yeah, I want 0. So you copy 0 over. J moves. Do you want 1? Yeah. So you copy 1. J1 moves. Do you want 2? No. So you don't copy it. And then J2 doesn't need to move. Then you're done with that. You're done with that column or that row because J1 falls off the end of the data there. So then you reset J1 to go back to the beginning and increment I. Reset. Oh wait, see that's where I put the incrementers in here. You don't reset J1 and J2 until I1 increments. Yeah, this thing here, I put these iterators. I put these with the indentation. I'm trying to show you where these guys get reset and incremented because that is a pretty confusing part, and I wanted to help you out with that. Anyway, this guy. Other than that, you're just writing some loops and turning this into executable code, and you know it's not a super hard assignment really. Anyway, I1 increments to the next row, and then you scan across looking for selected fields, and if they're selected, you copy the data over and move J1 iterator down. That's pretty much it. Okay, that's that guy. Let's look at join. Here's join right here. Join. This is join. So this is the hardest one. So here you have 2 row iterators and 2 column iterators, because actually you have 3 row iterators, I1, I2, and I3, because the resulting table is not going to have the same number of rows as either one of these. It's only going to have rows where the 42s match. So you need 3 separate row iterators, and then you need 3 separate column iterators. Get the first 2 functions working first, right? Can you see that? Get these guys working first, then come over here and tackle this dude. So here's the pseudocode algorithm I want you to turn into executable code. Let's see, what does this guy do? It combines rows. So you're going to scan 1 down, and then inside that you're going to scan 2 down, I2. If you find a match on column 1 in the first table, and column also happens to be column 1 in the second table, that's these 2 parameters that are passed in. If you find a match on the 42, then what do? You've got to copy all of this stuff over here, the whole row, then the additional rows from the second table. You don't want to copy the 42 twice. You only want to copy these 3 fields over to here, and then this extra field over to here. So what does that look like? So if you find a match on the 42 here, If you find a match, J1 scans all the way across, copying and incrementing J1 and J3 as you copy, 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 copy. J1 and J3 will increment. Then after that's done, you keep on, you go over to this guy and you start incrementing this guy, checking for duplicates. Okay, so you start with the J here, of course, and you check if it's not the same as the 42 cable column. And if it's not the same, then you copy it over here, incrementing J3 and J2, right? So J2 will walk across here, and J3 will continue from where he left off before. So these iterators show up in here without really a supporting loop structure. It's just kind of a weird way that they show up. Yeah, so if you don't have a duplicate, you copy the data. Otherwise, you just move J2 down, and J3 stays still. So you got this if-else in there. Okay, that's you find a match, you generate the new row. This is all the stuff generating a row in here, and then I1's gonna, first I3 is gonna move down, ready for the next table to be filled, or the next row to be filled, right? I3 will increment down so that he's ready to fill a row should there be a match. And you've got to reset all of these other pointers or incrementers. You've got to reset J1 and J2 to the beginning and J3 to the beginning. Then you got to increment I2 because we're still on the first iteration of the outer loop, right? So you want to reset, or rather you want to increment J2 so he's ready to look for another match. So I2 increments, and there's not going to be a match there. So there's not going to be a match. So here, it looks like I'm resetting these guys over and over again. That's just fine. It's easy enough to just reset rather than check if you actually need a reset. Just reset. It's faster than checking if I actually need a reset. Anyway, you're gonna scoot I2 down again. So now we're comparing I1 this row with I2 this row. We find a match on 42, and then the J's do their thing. J's do their thing, copying all. This stuff. Copying all of this stuff, and then this one, right? Copies these three guys. We're going to be at this second row now, and then it's going to tack on this thing onto the third field. Okay, that was the total scan of I2 with I1 at 0. Then the outer loop increments, and you look here, and I think I need another 42 in here, right? Somewhere I need another 42. That's a bug, because this finds a match on 42, generates 2 rows. There should be another 42 in here. Oh wow, that is a bug. Yeah, it's gonna find a match on this one, and it's gonna copy and generate these two rows. Okay, so that's that. I think I have a hand execution here of example 4 from earlier in the notes, where we're doing these 3 operations: select, join, and project. This is what that would look like in code. There's a select, a join, and a project. I'm generating a table called temp1 by doing a select operation on the buyers table, and I'm looking for column 0. Where's buyers? It's over here, right? Column 0 on buyers. I'm looking for the value United Supplies, and the result is this guy. This is what that looks like in code. You're scanning the buyers table. I1 iterator goes all the way down here. And when United shows up, you copy these 2 guys over to here and increment I2. Then United shows up again, and you do this one. United shows up again, and you do that one. There's 4 times. 1, 2, 3. I'm missing a United in here, right? Is there a missing United? 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. The first one. I was thinking that was the field name. Anyway, yeah, it's okay. So that's the select, right? And the code for these moving these iterators, that's this stuff. Okay, then we did what did we do next? We did a join operation, right? We did this join operation. So that's would look like in main you'd call you're joining temp 1 with temp 2. There's temp 1. Where's temp 2? No, we're generating temp 2. That's the output table, and the input table is temp 1. This guy, and the other input table is suppliers, which is over here, right? And then the columns that we're joining on is part number, which is column 1 in the suppliers table. Right? Is indexes. Column 1 we're joining with. Where's temp 1? Here, right? We're joining with column 1 in temp 1. That's what these ones are. It's this column in this guy, and this column in this guy, and yeah, and that looks like this. You've got the output table, which matches this, and I'm just showing the iterators here. And I'm going to go through so much detail on this thing. But anyway, that code is that. Then the last guy, is you have to select, for the project, you need to select somehow the columns that you want to extract. That's for the project. Did I say that? For the last operation, the project operation, you need to extract the particular column. So we need to indicate those. So I'm just... there's a columns array I've made somewhere. Is that declared in here? Anyway, there's a columns array, and I'm just marking the column 1 and column 2 with 1s to indicate that I need those columns, that I need them to be extracted. And those come out here. So see, I marked column 1 and column 2. And then you just scan this guy and these 2 guys, put them down in here. Okay, and that's the code for the... No, wait, that's the project right here. This is the project. The join was this was the join over here. Okay, it's the nature of this stuff. It's like table. There's just so much. It's like there's no way around that. Sorry about that. Hey, we're done. All right, cool. So yeah, so go ahead and do the book work on that, and I'll there'll be another video. I'm going to look at some code a little bit. Okay, hope this was helpful. See you next time. Bye.